Today we're going to be looking at the Fluoride pH probe. Notice that it's got a metal bulb instead of the typical glass bulb that we see on our standard pH controllers. So here we have the antimony pH probe connected, and you can see the reading is 12.46. This was calibrated previously to read 7 on a standard pH probe, but the reading is way off. Actually we're going to put it in, let's put it in the 7 buffer. Because the electropotential across the antimony bulb is different from glass, the calculation by the pH controller is different, so we need to we need to program it for antimony probe. So we'll enter the secret password of 1000, and the first option is measurement, and there are two choices, actually measurement mode. Here are the two choices: pH, standard pH probe, or antimony probe, which everyone remembers from high school. SB is antimony, so we'll select that, and you can see, and we'll escape out of this, and you can see right away the reading is around 7. So we're going to go through a calibration now, and because that too is different. So let's again enter the submenus. So and this time we'll go to calibration. And tech calibration is the standard 4, 7, 10 buffers, so we'll do that one. And today I have 4 and 7 set up on the bench. So now the first thing you notice is that the millivolt reading is not 0 like you would expect from a standard pH probe. It's minus 350. That's okay, that's expected, and it's going to compensate through its algorithm inside. So we'll call that's pretty stable, around 350. You know, it doesn't have to be exact, so we'll just say yes to that. And what we'll do is now put it in the 4 buffer. And that's the internal alarms that I set. So here we have, instead of minus 136 or so, we have plus 136, and that's also expected. So we'll wait for it to stabilize. The longer you can wait, the better, but we'll basically wait until it stops climbing. On these industrial pH probes, the either glass or antimony is thicker than a laboratory probe that you might be used to, and that's to resist abrasives and dropping and bumps that could happen in industrial online monitoring applications. So it takes longer to calibrate. So anyway, we're going to let it stabilize, and it looks like around 150 is where it wants to settle in. So we'll say okay. We'll say okay to that. And now we can check and see what we've got. So 93.4%, that's not a great number. We really want to see better than that, but just for the purposes of illustrating the calibration, it's good enough. So 4.01 in a 4 buffer, that's perfect. And now we'll just see what it does in this, reads on the 7 buffer. And again, it takes a little while. We can speed that up a little bit with some agitation, but not too much. It's the boundary layer that's clinging to the bulb that's really slowing down the diffusion of electrons. So anyway, so it looks like it's zeroing in on 7, so I would call that a successful calibration. So so that's pretty much the way to calibrate a fluoride pH probe.